Hey guys, this is the first tutorial for Boids. We're going to start off by dealing with the cohesion part of the tutorial and kind of go from there. We will deal with alignment in a separate video, and then you'll be on your own to do the, the separation as well as avoiding the trees. So let's take a peek. When you start this tutorial, you should have the initial direction of the Boid all set out. You should have its constructor completed, and so it should be running something like this. And so I've also added the check edges method. I've called that from the act method so that we can get these things checking the edges. You'll notice they're just kind of bouncing around between the edges. You'll also notice that the birds aren't exactly flying in their proper direction, so let's go fix that now. We're going to head up to the act method because these will always need to be changed. The direction of the birds will need to be changed based on the direction that, well, these birds are going. So in order to set the rotation of the image, we're going to have to call, of course, the set rotation method. And then what we're going to do is we are going to get the movement dot get direction. And that's going to make it so that our Boids are actually going in the correct direction. Let's compile that. And now you'll notice their images actually turn when they hit. If you take a peek at that bird there, yeah, it'll turn at the edges and actually go the direction it's supposed to go. Okay, good, so we fixed that. Now, we are calling cohesion. One thing that we're going to do is we are going to modify the constants that we created up here so that the margin as well as the force is sent to each method, both the separation, the alignment, and the cohesion methods. It's going to be sent to them so that we can actually kind of modify them slightly. So what we're going to do here in cohesion is we are going to send it force as well as margin. Okay, and down in cohesion, of course, we're going to have to say double force and int margin. I'm just going to double check that. Right, good. So we're all good there. Okay, so the first thing we're going to do is we are going to see if there are any Boids around us. Now, in order to do that, of course, we'll have to create a list of Boid objects. We'll call it Boids equals get objects in range. And so the range we're going to use is margin, okay, because in the future, you'll see we can easily change margin up here. And we could either make it a smaller margin or a larger margin, or increase the force and decrease the force away from the kind of base margin and forces that we had decided to use in the beginning, so that our algorithm runs a little smoother. So we'll do margin and then boids.class. Oh, not boids, boid.class. Okay. Then we need to actually see if there are any Boids in the list. We don't want this to say find an average, average point of the Boids if there are no Boids in the list, because that's just going to return 0 and it's not going to do nice things to our algorithm. If we look at this, what we need to do is we need to collect all these, each one of these Boids that are around us in this margin. So we've kind of got this round area here, and that's supposed to be the margin. We want to get all those Boids together. So we're getting them into a list, and we want to make sure that there are actually Boids in this list. So to do this, we're going to say if Boids is dot size is greater than 0, then we actually want to start doing things. So the first thing we're going to do, if this list is greater than 0, we're going to create variables for the total x and y values of each so that we can then get their average location. So we'll do int total x and we'll set it to 0 to start, int total y. Okay, and then we're going to figure out the average point between all the Boids. So we're going to have to actually go through this entire list of Boids, add it all up, and then, of course, average that total out. So let's see here. We actually have to use a for each loop. For each Boid B in the list Boids, we're going to want to do total x equals total x. And we're going to have to get their average point, so plus the current Boid we're dealing with dot get x. Okay, and then we're going to do here total y equals total y plus b dot get y. Once we've gone through that entire list and added up the total for each x and y, we then will average that out. So we're going to do double avg x, set it to, let's do total x. We have to divide this by how many Boids we had added up from. And of course that total is going to be Boids dot size. So average x is going to be total Boids divided by size. Then average y equals total y divided by Boids dot size. Okay, let's compile this. It's been a while here. Oh, it's not liking this. I've forgot a bracket. I'm going to put that bracket down there so we've got that done. What's happening here? Cool, cool. Okay. Can't really test too much yet. So the next part that we're going to do, we've got these average points for each. We're going to now calculate the angle using the tangent formula here. So the tan ratio, we're going to figure out this theta angle here based on the dx and dy values that we have. So the distance, it's like the opposite over adjacent. So we're going to say dy over dx. And we're going to use this math.a tan2 method to do this. We're also going to use the method 2 degrees, which will take a tan2 and its return value, which is in radians, and turn it into degrees so that we can use it. Okay, so we're already on this step. Use this to compute the tangent of the angle between this Boid and the average point of the others. So we're figuring out the angle. So let's head back here. So calculate the angle. Let's try this out. So it's going to return an integer angle back to us. Int angle equals math dot 2 degrees, and then we're going to do math dot a tan 2, and we're going to send it. Hey, wait a second, we don't even have the distance yet, so we can't calculate the angle until we have the distance. So figure out the distance. We've got the average points, but we have to figure out the distance. So I'm actually going to put this down here. Let's figure out the actual distance. So to do that, we are going to say int dist, we'll just say dist x equals avg x minus this dot get x. And note that we do not have to use the absolute values of this. In computer science, given that our our plane is not like the Cartesian plane with negative values on it, it starts in the top left-hand corner of the screen, we're not actually going to have to find the absolute value. This value that we're given will be just fine. So get y. So that should give us the distance. Now we can actually calculate the points. So dist y, opposite over adjacent, dist x. And this is going to return, I think, let's see, is it going to return a double? It might. Oh, well, this one definitely is. So let's do double here. Okay, and so this one, yes, we have to multiply this by an integer value. We don't multiply, but we gotta cast it. So let's see here. The last part of this is going to actually be applying the angle that we've got, as well as the force that was sent to us, or that we sent ourselves in this case, to this actual Boid. So let's try add force, new vector. And the vector is going to be angle, as well as the force that we were sent. Let's try this. All right, when we run it, what do we got here? They're flying around in a pretty cohesive group. Okay, they're going a little crazy right now. But you will be adding in a piece a little bit later that will make sure that they've got a maximum distance. It'll be the fastest they can go. We'll kind of deal with that during the cleanup of things. But they're starting to fly a little bit more cohesively, at least at the beginning. What's happening right now is they're going a little fast. And I guess we could fix that right now. I think we've got a little bit of time left to do that. What we can do is we can give them a maximum, basically a maximum speed. So I've got those variables created up here. Let's just do a max speed for now, and you can do the minimum speed on your own. So we're going to basically say if the movement of this, get movement, we're going to just double check. Smooth mover class, can we get speed? Oh, we do have a get speed. Let's just do get speed. So if get speed is greater than max, call it speed, max speed. Let's actually set the speed of this. Let's make sure we also have that method that we have available to us. Let's set the speed. There is no set speed, so we're going to have to use the thing in vector class called set length. We'll do that. We'll use set length. So we'll say get movement dot set length, and we'll set it to be max speed, so it won't go any quicker. And of course, round brackets there. So let's just try this, just see. Okay, so let's try running it. Okay, now they'll be quite cohesive because they're not going all wily crazy. Okay, so that, my friends, should give you a pretty good idea of starting off with Boids and getting that cohesiveness going.